Hello friends, in today's question, the average translation energy and the RMS speed of molecules in sample of oxygen at 300 Kelvin is 6.21 multiplied by 10 to the power minus 21 joules and 484 meter per second respectively. The corresponding values at 600 Kelvin are nearly, assuming ideal gas behavior. So we have to find out translation energy and RMS speed when the temperature is nearly doubled from their initial value. So we start from because this question is directly related to formula. We already know the relationship between the transitional energy and the temperature, as well as the RMS speed as well as the temperature. So we start from the translational energy. We say that average translational energy if it is represented as E, that will be equal to 3 by 2 Kb multiplied by T, where Kb is the Boltzmann constant. Kb is the Boltzmann constant and T is the temperature. So therefore, we can write based on the translation energy equation that our energy E is directly proportional to T. And we can now divide this E is equal to directly proportional based on two temperature. One is our 300 and another one is 600. So you can say at temperature is equal to 300 Kelvin, we can say that our energy at 300 Kelvin is directly proportional to the temperature which is our at 300 Kelvin. Similarly, we can write that at temperature is equal to 600 Kelvin, energy at 600 Kelvin is directly proportional to temperature at 600 Kelvin. Now we can just divide these respective equations. Let us call this as 1 and this as 2. So dividing 2 by 1 or finding out the ratio, so we can say the ratio of 2:1, we can write that our E energy at 600 Kelvin divided by energy at 300 Kelvin is equal to temperature at 600 Kelvin and 6 and temperature divided by 300. So temperature we simply substitute 600 by 300 and this comes as 2, and we are given energy at 300 Kelvin is given. So we can write that energy at 600 will be equal to 2 times energy at 300, which comes as 2 multiplied by, it is given as 6.21 into 10 to the power minus 21. So this gives us that energy at 600 is equal to 1.242 into 10 raised to the power minus 21 joules. So this is the energy at 600 Kelvin. This is the energy, translational energy rather, at 600 Kelvin. Similarly, we are going to find out the RMS speed. RMS speed if we write it as Vrms, then Vrms is equal to 3 multiplied by Kb multiplied by T and divided by M. And for here also we can say that our Vrms is directly proportional to square root of temperature. So once again we can divide this equation into two respective equations based on the temperature, and M is our, you can say, mass of one molecule of oxygen, so it will be same for both the cases. Let me write it here. M is mass of one molecule of oxygen, mass of one molecule of oxygen. So therefore you can say at temperature is equal to 300 Kelvin, we can say our Vrms at 300 Kelvin is equal to, sorry, not equal to, is directly proportional to the temperature of 300 Kelvin and its square root. And respectively for 600, at a temperature is equal to 600 Kelvin, we can write our Vrms at 600 Kelvin is directly proportional to temperature of 600 Kelvin. Let us call this as 3 and 4. Similarly, ratio of 4 is to 3. We can write that our Vrms of 600 divided by Vrms of 300 is equal to square root of temperature at 600 divided by temperature at 300. So obviously temperature we already know is 600 by 300. We are supposed to find out velocity RMS at 600. Therefore we can write that velocity RMS at 600 will be equal to, and this comes as 2 square root of 2 rather, multiply by velocity RMS 300, and which is given to us. So this comes square root of 2 multiply by, we have this velocity as 484. So we get Vrms at 600 Kelvin is equal to, this will be approximately 685 meters per second. So we found out both things. The velocity at velocity RMS as temperature, as well as we found out the energy at 600. Sorry. So we can write that energy at 600 Kelvin energy we found out is our 1.242 into 10 raised to the power minus 20 joules, and RMS speed is our 685 meter per second. And let me check if I have written correctly here. Yeah, it has to be 20. If the answer is in 20s, yeah, it is 21. So let me remodify it. So this comes as 12.424 multiplied by 10 raised to the power minus 21 joules. And let me do it here also. This comes as 12.42 into 10 raised to the power minus 21. Now it's correct. So the options comes out as, it is close to 684. Let me remodify that also. So this comes as option number D is the correct option. So it is close to 684. So option number D is the correct one. Option D is correct. So this question was quite simple, directly based on the formula. This completes the question. Thank you.